shapes of distributions and percentiles. So let's discuss how distributions may have multiple shapes. And here we have examples of histograms. The symmetrical distribution is one that looks like this. So it's symmetrical at the center. Oops. The uniform distribution looks something like this. All the values of whatever you're measuring, remember what you're measuring is usually on the x-axis, and on the y-axis the frequency. So all the whatever you're measuring, all the values have the same frequency. This is skew to the left. So the skew, when we think about skew to the left, we got to think about where the long tail or the lower values are. Skew to the right. And then we have a bimodal distribution with frequencies and maybe different areas of the values. It's not kind of continuous. And also we can have a multimodal distribution, which might be something like, more than 2 and so on. But these are the main ones. Here's kind of just the same graph focused on the same histograms. Another kind of distribution it's important to talk about, especially when we're talking about social media data and various kinds of natural events, is the power law distribution, which are highly skewed distributions. So power law distribution is one where there's a high frequency of low values or low frequency of high values and a low frequency of high values or vice versa. So for example, when we're talking about income, in many societies and situations, we have 80% of all income goes to 20% of the people. Or for example, in a lot of businesses, 10% of all the products make up 90% of the revenue. 10% of the products make up 90% of the revenue. These are what we call power law distributions, and they're common and they're not normal distributions that we'll see later. So when we're talking about shares of tweets, it's a classical power law distribution. And here is actually that histogram that I had previously graphed, where I cut off the first bin of the lower values to 200. And here is the whole in full. So if you notice, depending how you create the bins, you create different visualizations of the data. So this is one way to create the bin. At the end, I said, okay, the last one, just make it greater than 120 and divide each bin by 10. Here is a different way to do it. And you can barely see any of the data because just so much are just focused on the first one here. So I think this is a kind of improvement, at least to visualize the data. But to be frank, I did cut the data off here a little bit. So you would have to kind of want to show all the way that goes up to. And this last bin here is called overflow bin. And depending on the program you're using, you should be able to select the number of bins and the bin width. The bin width is here's 10, number of bins 13, overflow bin 20. And here, I'm not sure if I can move the video, but the bin width is 10. The number of bins is 13 and the overflow bin is 500, and creates a different kind of graph. So actually what just changed here is really the overflow bin. And the overflow bin kind of made all the difference. So an interesting exercise here. Random sample of weights of 40 females. What kind of distribution is this? What do you think? Pause the video and think about it. Well, I think this is a symmetrical distribution. Remember, this is kind of a bit crude, and it doesn't have to be precisely in this smoothed out form that it would appear if you had a density plot. But generally, I think this is a symmetrical distribution. And we know that because weights also follow a normal distribution. Weights of people, as a natural phenomenon, follows a normal distribution, which is this symmetrical distribution. What about here? This is random sample of grades on an easy quiz. Random sample of grades on an easy quiz. Well, it's kind of pretty clear, right? This is skewed to the left. Okay, let's talk about percentiles, and I'm going to stop here and continue on the next video.